Hi lads, in this video I'm going to go through page 52 of your Graphic Solutions booklet. I'm going to continue on with orthographic projection. So in this video we're going to look at the planes of reference and then actually drawing our first ever orthographic projection view of this prism here. So to start off the video we're going to focus on activity 6.15. It tells us the graphic shows a solid within the principal planes of reference. A. Label and identify the following: the vertical plane, the horizontal plane and the XY line. Illustrate how an elevation is projected onto the principal planes of reference by completing the partial elevation on the model, and then illustrate how a plan is projected onto the principal planes of reference by completing the partial plan of the model. So I just have the video actually here as well, just beside me, so you can actually see what I'm doing as I go along, instead of uploading the video separately. So the first thing is about creating the actual planes of reference. So when you're doing orthographic projection, you're basically projecting views of an object onto a plane. So for example, that backwards L block there. If we were to draw an elevation plan and end view of that, we project it onto our planes of reference, which are these things here. These actual planes look like sheets of paper, where one is standing up vertically, that one there, and one is lying down horizontally there. So next thing then, these planes are flat surfaces and they have no thickness. So they can go on for miles and miles any direction and they have no thickness whatsoever. And just for the sake of this question here, you can see that it actually has given a length and a width to it. But in general, planes can go on and they have no thickness at all. So a horizontal and vertical plane intersect to form the principal planes of reference. So where these two planes meet, that horizontal plane and that vertical plane there, where they meet together forming that L shape, that's going to be our principal planes of reference. So we have our vertical plane, obviously because that's the one standing up, so I'll just put that in there. And then we have our horizontal plane, and that's put in here. So they're fairly easy to remember. Think of a horizontal line and a vertical line. And then when the two of them cross, we get a thing called an XY line that separates the views. So that line there where they actually hit each other, the two planes, that's the XY line. And even though you can't see the Y in this question here, I'll just put it along here and just write XY line there. So that's what we've completed part A of. Label and identify the following: the vertical plane, the horizontal plane and the XY line. So after that then it's actually bringing in the shape we want to draw. So we want to be able to draw what looks like looking in the front, looking in from the top and looking in from the side. So basically our elevation, our plan and our end view. So in orthographic projection, each view is projected onto a plane. So you can see it's already started here in this, where we're projecting our lines out. So it's already taken the bottom one, that one there, and this top one here. So we're starting to get the outline of that backwards L, what we see looking at the front, what we see in looking in this way here. And looking perpendicular to the vertical plane will result in a view from the front, which we just mentioned there, the front elevation, what we see when we look in this way here. And the front elevation is also projected onto the vertical plane. So you can see our vertical plane there, that's where our elevation is going to go. So you can see the solution there drawn out already. So the front elevation goes on the vertical plane. You can see there all the lines are being projected onto it. So what I'll do is, I'll start projecting some of my points onto it as well. So just get my set square and line them up like this. So it's a slight angle, so either you could do the way I'm doing, holding the T-square up like this, or you can turn your page around to make it that your 30-degree line, your 30-degree set square will actually work. So if you imagine if we had the page turned and it just worked like that instead. So I'm just going to use my set squares for it. So just fix up so you can see the question there. And we're projecting all of our lines. So you can see the front is this part here. So I'm projecting that point out there, which is already done. This one out is already done. Next one is this one here, so I'm just going to project that out. and I'm going to project that one out as well. As we can see with the question, the lines are staying vertical. So what I want to do now is draw my baseline, which is already put in there. We can see that this line here is parallel to this one, and this one is also parallel to these two. So what I'll do is I'll get my set square and make a parallel to go back to there, because that's where it stops. You can see the line goes back to there. There's that point coming out, it stops there. Then it goes straight up, just like that one there. Goes straight up to hit that corner there, which is now out here. And the last thing, draw parallel again. So remember, these lines are all parallel, and we draw this one. That gives us our elevation there now drawn. So this is only in a 3D model. You wouldn't have to do this in an actual exam. This is just showing what's actually going on in 3D. You'll be drawing the 2D ones, which we used to see on the other activities. So back to the actual video. So now we've done the front elevation. Next one, if we look perpendicular to the horizontal plane, so basically looking down this way, so remember, if we were to just draw it out here, that was a horizontal line, i.e. a horizontal plane, and we look perpendicular, basically look straight down top of it, that's our plan view. If we look perpendicular to the horizontal plane, it will result in a view from above the object, and that's the plan view, what we see when we look straight down on top of something. And there it is there, put in as plan. The plan is projected to the horizontal plane, so all these lines are going to be taken down onto the plan. So you can see there, all of them are taken down, and they produce that view there. We can see the orange block and we can see the yellow block there. So I'm going to do the exact same as well. So this first one is taken down already for me. After that then, I take down this one next. I have this section here. I have the back one here. And then this one's already been put in for me. And then all I need is this back corner here. So what I'm doing is I've taken down this one, this one, this one, this one. That's for the back rectangle you can see there in the video. And then I've taken down this one, this one, this one, this one to the front rectangle. It's the same idea again. I'm going to start by drawing the lines going across this way. So I go parallel to here. And that line goes across. So this line here is this line here. It starts here and it ends here. Then what I can do, I can draw my line going back the other way. So it starts here, and the first one ends here. So I'm just going to go back to there for now. And then I can see that after it goes straight up, so we look down top, that's going to be a point there. It goes further back then to this corner, which is down here. And then when I go back this way, this one, which is here, connects to here. So this point here connects to this point here. And the last one, this corner here, connects to that corner there. And that's drawn in our plan view, so what we see when it looks down on top of it. And then that's what we have then, our elevation and our plan. And the last video we would have looked at drawing an end view as well. And we just went into detail about what an end view was. Just basically looking in at the side of it, looking in this way here. So this video is actually going to go through in a bit more detail now. So to give more information on the solid, so basically what we're talking about this thing here, an end view can be projected onto an end vertical plane. So in this question here, they don't actually have that drawn in for you. But in the video it shows it clearly here. So an end vertical plane is going to be a plane standing up but on the end here. So end view looking in this direction here. There's our end vertical plane, and projecting all of our points out. And what we see when we look in this way here, so you can see that that blue box there and the purple box above it. And then what happens is, because it's a 3D model and we can only draw on 2D paper, all the three planes are then folded out flat. And the planes are hinged or rotated about the lines of intersection. So the lines of intersection are these lines here. And remember, this one is going to be our XY line. So where all the planes meet, you can imagine like a door hinge being put onto it, and then we roll them out flat. So you can see there the idea how it's being rotated out. And the end view is now over here. The plan is being floated or being rotated down, and the plan is now down there. And that's what you imagine when we would have seen our previous questions. How we would have seen an elevation looking in this way, and I told you how the plan always goes below it. Now you can see why. When it's folded out flat, the plan is always below the elevation, and the end view goes to the right here. So this makes it possible for us to draw 3D solids in 2D. And that's what we would have on our actual page then. You can see the three views there, the elevation, plan always below it, and the end view beside it. So next activity then, so hopefully that actually helps there understand it. Next activity then tells us explain the following terms. First one is the plane. So a plane is a flat surface with no thickness, so we're going to put that in. So plane is a flat surface with no thickness. And then the principal planes of reference are basically the horizontal and vertical reference so the horizontal and vertical reference planes onto which orthographic views are projected. So basically the plane is like that surface there, and that surface there. And remember, it's zero thickness, so it doesn't actually have like an actual thickness. And also it goes on as far as it wants to go. It has no length at all to it. But just for these questions here, we actually define and say we want it to be this width and that length there. And then the principal planes of reference are the two combined here together to give us our orthographic views, and also our third one as well that will go out here that you would have seen in the video for the end vertical plane. There our orthographic views are projected onto and giving us our planes of reference. So the next thing I want to look at is activity 6.17. So this one here is telling us draw a sample of each line type in the table below, identify where this line would be used. I'm just going to put it up here so you can see it. So the type of line used in drawings plays an important role in enabling 2D drawings to be interpreted. So when we're doing orthographic views, there's different types of lines we need to use. So first one is a continuous thick line, what we would basically say in class like a heavy line. Draw that in there. Just like that there, a heavy line. That would be anything that's visible, so like the actual outlines of something. So what we put down there is visible edges and outline. And that's basically telling us like our final our final detail. So you'll see later on in the video when I do this part here, you'll see where I'll be using some of these lines. The next one is our continuous thin line. and we will call that as our construction line or light line in TG. And that would look something like this. We'll just draw a light line like that. It's not heavy, it's just light, and it can show the difference moving from one view to another, or if you're bisecting a line or bisecting an angle, you'd be using light lines because you don't need to see them in being as heavy as the rest of them. So they're used for projections. So that would be like these lines here, projection lines. So you notice I drew them ones in heavier than the lines coming down here and the lines coming out. And also the person did the booklet and the exact same thing. Them lines are heavy and the lines you projected out first are light. So they're projections and dimension lines. So when we're measuring something we would use light lines as well. And also something called hatching, which we'll look at in the future. So you don't need to worry about hatching now, but that's something we'd look at in the future. Next line is a dashed thin line. So a line like that. So you might not be able to see it as clearly there. So a line like that. And that's known for hidden detail. So we are drawing something that you can't, that's actually there but you can't see it. So it might be something that's been blocked at the back. So hidden detail. An example would be maybe in our masking tape. If we look down top of the masking tape, we can see two circles. But if I look at the front of it, I can only see the outside line here and the outside line here going straight down, but also there's going to be two inside lines there and there. They'd be hidden detail lines. You can't actually see them, but they're still there, so we put them in so we can show someone there is something there but you just can't see it. After that we have a chain thin line. So that's, for example, if you're drawing the centre line of something, or if you're showing something symmetrical that's the exact same on one side as it is on the other. Like for example, once again the masking tape. If I drew a centre line down there, it's the exact same on both sides. It's a smaller semicircle there, small semicircle there, bigger semicircle there, bigger semicircle there, symmetrical, same on both sides. You probably learned that in primary school as well about symmetry. You can say that a butterfly would be symmetrical as well, its wings, they're the exact same on both sides. And that line is just drawn like this, kind of like a shorter line, a longer line, a shorter line, a longer line. It's almost like a dot nearly appears as, but a shorter one. And that's showing centre lines, lines of symmetry, and then the last one it says for pitch circles. So that's something we'll be looking at in the future. Then the next one we have is a continuous thin irregular line. So that's just like a squiggly line. That's something we'll be looking at in a future stage, so you can just leave that out for now. And the last one, chain thick thin at ends. Once again, you don't need to worry about that now. It's for cutting planes and section planes. So we'll just leave those two blank. And we'll come back to them at a future date. And that completes activity 6.17. The last activity you're going to do on the page is going to be activity 6.18. Activity 6.18 is going to be getting you to actually draw an elevation plan and end view of this solid here. So the plan of the prism shown in the graphic to the right is given. Complete the orthographic projection of the prism by A, projecting an elevation, given that the prism is 65 mm high. So we're basically told the height of this, if I just put that in there, is 65, and projecting an end view of the prism. The first thing I need to do is just fix my page just slightly off there. basically draw an elevation, plan, and end view. What I'm going to do for this question is I'm going to put a bit of colour into it so we can actually see. I'm going to talk you through each view as well. So what they've given you so far is the actual plan in the question. So you can see there when I move the actual T-square, you can see there, they've actually drawn the plan, what it looks like looking down top. So we'll say a plan there, looking down top of it. Now for this question here, this view is going to be the elevation. And this one is going to be the end view, looking in this way. And I'll tell you why now. So if we remember from the previous views here, the elevation was looking in this way and the end view was looking in this way. And what we had, if I just go back to this part here, just where they roll it out flat, you'll be able to see this now. When we look at our 3D view and our 2D view side by side, there's our 3D view there, and I told you the elevation is looking in this way, the end view is looking in this way. When you're actually drawing out these questions, you want to figure out which side is the elevation going to go on, which side is the end view going to go on. Because remember, it could be the other way around. The elevation could be over here, the plan underneath, and the end view could be this side. Whatever way the arrow is pointing, that's the easiest way to determine it. So if the arrow is pointing this way for the elevation, that's pointing towards the left. That means the end view has to be to the right. And if we look at our question here, there's no room over here to actually draw another view. So that's telling me that the plan is below the elevation and the elevation is going to go on the left, because we're going to draw our end view to the right out here. We can't project a view out here, it's going to go into this view. So what we have is, we have our elevation pointing to the left, and then we have our end view pointing to the right. So the end view is going to go over this side, the elevation is going to go over this side. And remember that the plan always goes below the elevation. So the first thing we need to do is, we need to project our lines up. So remembering when the elevation, our plan, these widths are going to stay the same. That prism isn't going to get any wider than that. So we take them two straight up and we draw on an XY line. And for this question I'm just going to say the XY line is 20 mil up. You could say 10, you could say 15. I'm going to say this 20 mil up. I'm going to draw a line across there. And that's my XY line. Like this line here. So at the moment I have the plan view. So imagine like that's our plan view there. This is our plan view here. Just bring this back over so you can see. Move it over there. So we have our plan view drawn. If I bring it forward to the actual question. So it's showing the view there. And they say for the example of the question here, it's set to 10 mil. I'll just go back there again. So they have a 10 mil and they drew their XY line like I did there. So I just did 20, it doesn't really matter, once it fits in the actual page. They're going to project all their lines up to draw their elevation. There's the two lines projected up, and they've used light lines like I have as well, so their lines are in red showing light. You then take your height 65, and that height there. And then we draw in heavy. Our elevation. So another thing to remember is the heights don't change as well. When you're looking at the side of that, it's still going to be 65 mil tall. So I can project across a light line there to show that my height isn't going to change. And also the width isn't going to change. When I look in this way, I'm looking at this side here, and I'm basically taking that and turning around this way so I can see it. So them widths aren't going to change either. So if these ones stay the same going up here, these ones have to stay the same going up here. So I'm going to get my 45-degree set square. And by using my 45, that means the distance between here is 20 which equals this from here to here being 20 as well. So that distance from there to there is the same as there to there, two parallel lines. They can be taken up lightly. And now I can draw in my end view. I'll just use colours then to show it. So I'll just say that my elevation is this green line here. Sorry, this green section here, looking in that way. There's my elevation there again. Then my plan, so what I see looking down top of it, I'm going to draw that in blue. And then my end view, I'm going to draw that in red. So I see looking in this way here. And that completes my elevation, plan and end view. The last thing I'll do is I'll just draw a few light lines and actually label my view. So I'm telling you that that's my elevation, that's my end view, and that view there is my plan. And I've written it all in block capitals so it's clear to read. And just to see in the actual video here again, you see they drew in their elevation, and they're saying looking perpendicular to the end vertical plane, so looking in this way, the yellow side, you'd be able to see your end view. So they're showing that idea there, it's projected onto the principal planes of reference, the heights are taken across, and then separate 45-degree lines. So what they've done is, same idea as me, they're projecting up at 45 degrees. So they've drawn a little, you can see, 45-degree line coming out here first. What I've just based on is the exact same thing, except just taking my 45-degree line up that way. So you can see what they've done actually is this. And you can do this either as well if you want. They've drawn their line at 45 degrees. They've taken this line straight out and then straight up, and you'll see it's the exact same thing. It's just a few lines extra to draw if you do it this way. So I just take them out at 45 degrees because you're going to get the exact same point either way. So it doesn't matter if you do it that way or not. Once you just take your lines at 45 degrees from your ends, that's the most important thing. You can see there they get their widths then, and they can now draw their end view. And they've labelled it their front elevation, their plan, and their end view. And they're just using the colours based on the colours they actually have for the question. I just used the colours that I had there for it. And that completes activity 6.18. So the following activities that you're going to do in the next class are going to be basically redrawing the likes of these just with different shaped objects. So hopefully that video helps anybody who may have been stuck on that page. And if anybody has any questions, you can just message me on Teams.